So the domain of 1, f of x, x plus 1 over the root of x minus 7. So the hint was saying, get the domain of the numerator. So x greater or equal to -1. Get the domain of the denominator, x greater or equal to 7. So if I present them here, they will look like this: -1, +7. So x is bigger or equal to -1. So it will start from there, going this side. X again is bigger or equal to +7. So it starts from here. Then I'll get the intersection. So the domain is from 7 to +infinity. Like that. Who got it?
I did.
Only one.
I got it.
Good.
So I have a question. Well, for me, okay, on that one for 7, why is it, how can I ask this? Okay, why is it x greater or equal to 7? Why not?
Good. So for the denominator, is just greater than 7. So it's just greater than 7. Meaning that the top part there will be open. So the domain also must be open. Why? Because we don't allow a 0 in the denominator.
Okay.
Yeah. Okay, let's see the second one. What was the second one? It was f of x is equal to x squared plus 3x plus 2 plus x minus 1. Okay. So f of x, the root of x squared plus 3x plus 2 plus the root of x minus 1. So you can, minus 4. So you can start from x minus 4 must be greater or equal to 0, implying that x should be greater or equal to 4. That's the first thing. Second thing, the hint was saying factorize this. So the product factors, so we'll have to use x and 2x, meaning 1 and 2, giving us x plus 1, 2, x plus 1. So that x plus 1, x plus 2. Then equate it to 0. This is where it was saying get the critical points, the critical values. So x plus 1 is 0, or x plus 2 is 0. So x is -1, x is -2. So what does it mean? We now introduce a table or a number line. So we use the number line. So -2 here, then -1, a number bigger than -1, 0. A number in between, because there's no whole number in between, we'll add -1 plus -2, giving us -3 and divided by 2. So -3 over 2, and then get -3 from this side. Okay. Then test now in the actual function. So we can even use x squared plus 3x plus 2. Remember, this guy must be greater or equal to 0. So if we use -3 here, we have -3 squared plus 3, -3 plus 2. That is 3 minus 6. That is 3 minus 6 plus 2. I mean, that is 9 this side, minus 6 plus 2. This is what? This is 11 minus 6, 5. Positive is our interest. Then we get negative 3 over 2, have it squared, plus 3 minus 3 over 2 plus 2. So we have 9 over 4 minus 9 over 2 plus 2. So 4 down. Then we have 9 here minus 18 plus 8. 9 plus 8, we get 17 minus 18 over 4. This is negative 1 over 4, so we get a negative there. We place 0, it will be 0 squared plus 3, 0 plus 2, which is 2, positive. We want where it is greater or equal to 0, so we get this piece and that piece. So the solution set for that part is from negative infinite all the way up to negative 2 included, union negative 1 all the way up to positive infinite. But our domain is the intersection of this part is the same as 4 to infinite. So we intersect that piece to this one here, negative infinite, comma negative 2, union, negative 1, comma infinite. This intersection 4 to positive infinite. So you understand that this one and this interval do not intersect. This one is ending at, we have negative 2 here, negative 1, positive 4. The other one starting from here going this side. The other one starting from here going this side. The other one starting from here going this side. So this piece does not intersect with this piece. So you forget about this piece. Then from negative 1 to infinity and 4 to infinity, how you get the intersection, the easiest way, between negative 1 and positive 4, you get the bigger number, 4. Infinite and infinite, you get the smallest, but they're the same. So you get that. So this is our domain for that function. Did anyone reach this far?
Yes, sir.
Yes.
Yes.
We are doing fine, eh? Okay. So this is how we'll be asked. After doing things that looks a bit simple, you go in an exam, you meet such complicated things where you have to solve for you to get to what you were told is when you have a product, you do this. So you have to look for that product yourself. But once you get the product, then you know, oh, now I have a product. So what do? I need a table or a number line. From there, I intersect the two intervals. Then have a solution set. Okay, so we continue then. We continue with question 6. We are now on number 2. F of x is equal to x squared minus 4x. Do we get an inverse here? Find the inverse of the following functions defined by the following equations if the inverse exists. If the inverse does not exist for the largest possible domain, limit the domain so that the inverse will exist. So you have this function x squared minus 4x. One thing we should take note of is that a function f has an inverse if f is 1 to 1. But if you look at f of x is equal to x squared minus 4x, this guy, we need to check if it is a 1 to 1. Because looking at it here, you can see that you can't easily solve for x. There'll be so many issues if you try to solve for x here. So because the guy looks like he didn't have, we can't easily solve for x, let's try to see if it's a 1-to-1 function. A function f is 1 to 1 if f of x is equal to f of y, implies x is equal to y. Meaning, if we say f of x is equal to f of y, what we mean is x squared minus 4x or y squared minus 4y. These two are equal. So let's try to solve for x if we are able. You will notice that if you force things here, it will be x squared. Okay, let me solve for, let me factor out this guy. And I won't factor out on the other side. So we have two values of x. Okay, if the other part there was 0, x could be 0 or x could be negative. I mean, or x could be 4. So this means that f is not a 1-to-1 function. Hence, f has no inverse. Then they are saying limit the domain then for you to find the inverse. Because what is making it to fail to have an inverse is because it's not a 1-to-1 function. So can we limit it and have it as a 1-to-1 function? How do you do that? Okay, f of x is x squared minus 4x. So complete the square. Complete the square. We'll get x squared minus 4x plus the half of x. Since a for x squared is already 1, so the half of the coefficient of x is 2. We'll have it squared minus the very square. So we'll get x, get the minus there, and get the 2 squared minus 4. So now, if you try to sketch this, it's saying at 2, 4, it will have a minimum turning point. At 2, -4, sorry. At 2, -4. So let me draw it. At 2, -4, it will have a minimum turning point. If we equate it to 0, we'll have this is equal to 4, giving us x minus 2 is equal to plus or minus 2. So x minus 2 is 2, or x minus 2 is -2. So x is 4, or x is 0. So by graphing, the function would look like this. That is 4, and this piece here is 0. So the reason why it's not a 1-to-1 is because of this shape. So if we cut it at the line of symmetry, so we'll say this function All right, I'll send. So this function is now defined as the very f x minus 2 squared minus 4 for x greater or equal to 2. It's the same function. F of x is x minus 2 squared minus 4 for x less than 2. So it has two domains, but so you talk about each domain independently if you have to have this function invertible. But of course, you can't easily obtain that domain, that inverse. But you just say my f will be invertible for this domain and also invertible for the other domain, because at this point now, we are saying y is equal to x minus 2 squared minus 4. So we have y plus 4 is equal to x minus 2 squared. We can square root. So that x minus 2 is equal to the root of y plus 4. So x is 2 plus the root of y plus 4. Remember, it was supposed to be plus or minus. So because we have limited the inverse, so we are saying f inverse is equal to 2 plus root of x plus 4, or f inverse of x is equal to 2 minus root of x plus 4. So meaning each one has its domain. So the minus one takes x less than 2. The positive one takes x greater than 2. So that's how you get the inverse.
Sir, kindly repeat on that part which says x, the previous screen. Yes, on that one, my network was cutting.
Okay,
just from the part of where you got the y plus 4.
Okay. So since we have equated, we've factorized, and it came out to be x minus 2 squared minus 4. Whenever we want the inverse, we let the whole function be y. So it will still be y. And then so for x, so it will be y plus 4. This guy goes the other side, remaining with x minus 2 squared. If we square root and square root, we know that x minus 2 should come out to be plus or minus the root of y plus 4. But we have limited the domain so that we just say x minus 2 is equal to the root of y plus 4 when x is greater than 2. Meaning x is equal to 2 plus the root of y plus 4. So f inverse for this piece is 2 plus the root of x plus 4 whenever x is greater or equal to 2. In fact, here we allowed x to be equal to 2 as well. Here. Or x minus 2, I'm back to this one, is equal to the root of y minus 4 negative now whenever x is less than 2. This means x is equal to 2 minus the root of y minus 4 if x is less than 2. So f inverse of x is equal to 2 minus the root of x minus 4 whenever x is less than 2. This inverse is only defined for these domains. and not on the whole real line.
All right, I get it. Thank you.
Okay. Yes.
I also have a question.
Please ask.
I'm a little bit behind on how you prove that it's not the one-to-one function.
So on the proving of one-to-one, in fact, the insight is that for as long as I have a square here, and I try to solve for x, I'll get two values of x. So I can do the solving. When I reach this part, then I will know that x is taking two values. Suppose y is 0 at that point. Suppose this part here is 0. You would get x is 0 or x is equal to 4. So I know that x here is not a one-to-one. In other words, we have failed to find x is equal to y.
Okay.
Yes. Okay. So this was part 2. Let's see part 3. Part 3, f of x is equal to x over x minus 3. You let y be x over x minus 3. Also here, before we move, what is the domain for f of x? The domain is all real. There's no limitations there. X squared, x, any value of x you take there, the function will be defined. That's the first thing. What's the range? The easiest way of knowing the range here is using the graph, since I've already graphed it. So the range from the graph is from -4 going to infinity. Complicated? You look at remember, we are saying that the domain of the inverse is the range of the original function. So let's come to the inverse. What's the domain of the inverse? The domain of f inverse So in fact, this domain is reminding us that here, we must not put the 2's here. We must put the actual domain where x is greater or equal to -4. And here, x will be less than. No, for both. So there was an error here. There was an error inside here. It's supposed to be plus for both. So it's x plus 4, x plus 4, x plus 4. So even here, x is greater or equal to 4. So I get the domain of this. The domain of this piece here, which forms the domain of the whole thing. So it's -4 to infinity. And since we said that the domain of f inverse is the range of f, so we'll do the same, -4 to infinity. And the range of The range of F inverse is the domain of F. So the range of F inverse is equal to the domain of F, meaning that it is R. Okay. So when we are using, so this statement here is very correct. When there is 2y in here, this 2 is correct when there is 2y in the inside, because we cannot have x outside and x inside. So there's 2y here, there's 2y here. So that information is very correct that far. Until you change from y to x, that's when now you will change your x to 4. So we have found the domain for the inverse, the domain for F, the range for the inverse, and the range for F. So that statement of the domains of the inverse of the domain of, that's a very important statement. Okay, so we carry on here. We say y is equal to x over that and look for x now. So over 1 cross multiply, we'll get this is equal to x. So yx minus 3y is equal to x. So we get yx minus x is 3y. X, y minus 1 is 3y. Divide by y minus 1, divide by y minus 1. So x is equal to 3y over y minus 1. That is F inverse of x is equal to 3x over x minus 1. So what's the domain of F? The domain of F is Ox, a real number, such that is not equal to positive 3. This is the original F. Remember, the denominator must not be equal to 0. It can only be 0 when x is 3. Immediately you have the domain of F, meaning you also have the range of F inverse. But this time around, the range is in terms of y. So you say y, a real number, such that y is not equal to 3. That is the range of the inverse. Then the domain of the inverse will be x, a real number, such that x is not equal to 1. This means that the range of F will be y, a real number. So no confusions here. Will be y, a real number, such that y is not equal to 1. So I want you to see how the same domain becomes the range by switching the variables. So you always start with a domain, then you make it the range, if they have asked you to find the range. Range mostly comes from the domain, because I've understood that the domain of the inverse is the range of the original function. So we go to 4, f of x is equal to 2 minus x. This one is a bonus. So you say y is equal to 2 minus x. So x is 2 minus y. This is F inverse of X. 2 minus X. The domain is ORU. The range of the inverse, of course, it's ORU because it's equal to the domain. The domain of the inverse, so this was the domain of F. The domain of the inverse, again, it's ORU, it's just 2 minus X. So whatever value of X there will be to be defined. So the range of F will also be ORU. Those are normal functions. Let's see this one, the root of X minus 4. The root of X minus 4, or it's X squared actually inside. X squared minus 4. So let's try to get the domain first. I mean the inverse first. Is it invertible? So we have Y here, X squared minus 4. Have it squared, have it squared. So we have Y squared is equal to X squared minus 4. So Y squared plus 4 is equal to X squared, implying that X is equal to plus or minus the root of Y squared plus 4. So what does this mean? This means that F inverse of X is Y squared plus 4 on a condition that X is greater or equal to 2 and F inverse of X is equal to negative Y squared plus 4 on a condition that X is less than 2. So now that I've written the inverse outside, you come back and change the variable to X squared plus 4, X squared plus 4. You're just cutting the domain because if you sketch this function, now the sketch won't be well explained because of the minutes remaining. But you notice that you have from 3 and negative, I mean from 2 and negative 2. Negative 2 and 2. When we get the domain of F, it will be X squared minus 4 greater or equal to 0, meaning X minus 2, X plus 2 greater or equal to 0. So it will be from negative infinity to 2 included union negative 2, from negative infinity to negative 2, to from negative infinity to negative 2, union 2 to infinity. And it is going up, it's going up like that. So the inverse can only be defined for this section going to the right, meaning X greater or equal to 2, and for this section going to the left, meaning that X less than 2. That's how you obtain the inverse of this function. So now, what will be the domain of F? We have already found it here. That's negative infinity to negative 2, union 2 to positive infinity. So the details of going through the table and the like is what we are doing in the other lesson. So I expect you to be able to just match. We had a question of this nature, X squared minus 1. So we said X minus 1 and X plus 1 get equal to 0. So whatever we did that question is exactly what we have done here, except we have not just shown the working. So this means that the range of the inverse has also been found, negative infinity to negative 2, union 2 to positive infinity. That's the range of the inverse. Then the domain of the inverse is all real. So the domain of the inverse, I mean the domain of f, I don't know where it's been found. The domain of the inverse, I mean. The domain of f inverse. Okay, we'll be cut in time soon. So we should rejoin back so that we finish this story sheet. At least this story sheet should be finished today. So let's rejoin immediately we are cut off. So you guys should finish the domain of the inverse and the domain of f. I mean, and the range of f from 0 to infinity for both.